Today is Tuesday, May 19th. I have my microphone appropriately attached and plugged in. Sorry about that. Forgot to plug it in yesterday. So today we're going to continue with the mix review, chapters 1 through 12. We're going to do problems 41 through 48. And let's start off. It says use the discriminant to determine how many real number roots the equation has. Do not solve the equation. So when we talk about the discriminant, we're talking about the quadratic formula. And the quadratic formula states x is equal to the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Now the discriminant is going to be this value right here. The discriminant is equal to b squared minus 4ac. Now we had talked about this a little bit earlier. So when this value is greater than 0, that means we can take the square root of that value because we're going to get a value that is greater than 0. So we're going to get a situation where we'll get two solutions, because we can always take the square root of that. When the discriminant, however, is b squared minus 4ac is equal to 0, when we get the square root of 0, well, we know that when we plus or minus, we're going to get the same value. It doesn't affect that opposite of b over 2a because it's going to be plus the same value. So when we get this situation, we're only going to get one solution because that discriminant will not, ends up being 0. So it won't affect anything in that fraction. And then the other situation is when b squared minus 4ac is less than 0 or a negative number, we have this when we get plus or minus the square root of a number less than 0 or a negative number, we're going to get no solution. Well, technically, and remember, it will just be a negative number. So what they say is two imaginary solutions. And you get two imaginary because the square root of -1 equals I. And I stands for imaginary. So that's a mathematical way of, instead of stopping, well, let's talk about a way that you can solve something. So let's go through what these look like. So the parabolas, when the discriminant, the parabola is going to have two intercepts. So it's going to look like this. And we've talked about this. This is going to be my intercepts. When your discriminant is greater than 0, it's going to cross the x-axis. When you have one solution, let's move this over here. When we have one solution, when our discriminant is equal to 0, our parabola excuse me, is going to hit right on the x-axis. And reason being is that's the only way you can get one intercept is when it pops right off of it. Now it can be anywhere on it. It doesn't have to be on the positive side. It could be over here. It could be right here. But we know that it's only going to have one x-intercept. Now, when we get two imaginary, that means that the parabola does not cross the x-axis. So it can be that situation. Something to keep in mind, however, and this is where there's always, our parabola can be upside down also. And you would still have two intercepts. So just understand that you still might have this situation. That was a bad one, sorry. So notice, even when it's upside down, it's still going to have only one. And then this situation could be something like this, where it never touches the x-intercept. So, and that would be when our a would be negative. Our parabola would be upside down. So that's what they're talking about when they ask about determine how many real number roots real number equation has. So these are real numbers, so we're going to look at b squared minus 4ac. So our b is -3. Let's do this. A equals 1, b equals -3, and c equals 5. Remember, it always has to be equal to 0. So we end up with, and we get 9 minus 20, which gives us -11. So since this is less than 0, there is going to be, our answer here is going to be no solution. So how many real number solutions? And it'll be none. If they asked you how many solutions later on in Algebra 2, we would say 2 imaginary solutions. But under the question that they're giving, it says how many real number roots. I guess none would be the better answer. There are no real number solutions. Let's look at the next problem. So here we go. It's set equal to 0. My a is equal to 4. My b is equal to -12, and c is equal to 9. Now, let's go back to this for a second just to expand on this. This is not the solution to this equation. Remember, it says do not solve the equation. We're not solving. This just represents the discriminant. It represents this part of this equation. So we haven't done all the work, but we know some information from the discriminant. We know what we can expect from our graph. So we know our graph is going to look something like this. All right. So now let's go back. We've got b squared minus 4ac. b is -12, quantity squared, minus 4 times 9, which is 144. 36 times, no, 36, 16 times 9 gives me 144. 0, so how many solutions? We're going to get one solution. And it's going to pop off of the x-axis. It's not going to go through the x-axis. It's going to just dip right off of it. So this middle one, this one here, we're talking about that. Good. Okay, so that's what the discriminant tells us. It just sort of helps us, what can we expect that graph to look like? Let's look at the word problem. When 3 times a number is increased by 7, the square root of the result is 7. Find the number. So when 3 times a number is increased by 7, the square root of the result is 7. The square root of the result, is 7. So here's our example. Here's what we would transcribe that to. So first thing we have to do is we have to square both sides in order to get rid of the square root. That gives us 3n plus 7 equals 49. We don't do plus or minus because we're not taking the square root of a variable being squared. And now we solve. Minus 7, 3n equals, what's that, 32? 42, Mr. Mac. 42 divided by 3, n equals 14. So that would be my answer. And when 3 times a number, so 3 times 14, let's check. 3 times 14 equals 42 is increased by 7. Let's add 7 to that. It gives us 49. The square root of that, square root of 49 is 7. Yes, it worked out. Express each rational number as a terminating or repeating decimal. I love this. So let's do 18 divided by 25 gives me 0.72. As a terminating or repeating. So this terminates, it stops in the hundredths place. That's nice and easy. Let's try this. 13 divided by 15 gives me 0.86666 repeating. You see the 7 at the end. That's just the calculator rounding. It looks at that place. It continues to go on forever. So if we want to write it as a repeating, we would write 0.86 with a repeating sign only over the 6. And that represents all those 6's repeating forever. You cannot write this. It is whatever is repeating needs to be, that is incorrect. This is the only answer you can write. And you should have a 0 on the front. 1 4/9, so let's do 4 divided by 9 gives me 0.444. So we have the 1 in the whole number, and then we have 4 repeating, which is 1.4 repeating. And we'll notice, hey, 4/9, you should know this. 4/9 equals 0.44. 7 divided by 9 equals 0.777. 5 divided by 9, 4 divided by 9, pretty cool. 1 divided by 9. What do you think if I do 11 divided by 9? What do you think I'm going to get? 11 divided by 9. Oh, that's pretty interesting. What about 14 divided by 9? Oh, did you see that pattern? What if I do 11 divided by 99? What if I do 13 divided by 99? What if I do 14 divided by 99? Pretty cool, huh? What do you think I'm going to get when I do 29 divided by 99? Yep, pretty fun. What if I do 103 divided by 999? So some fun stuff there. All right, let's graph. We have this inequality. It is in standard form. We have to remember that when we have less than or greater than, we're going to have open circles and dotted lines. When we have less than or equal to or greater than or equal to, we're going to have closed circles on our points and solid lines. So in this case, if I look at my x-intercept, remember this is in standard form, I'm going to cover it up and I am going to solve for that variable. So let's do, something purplish today. So if I cover that up and solve for x, I get an x-intercept of 3/2, or 1.5. So at 1.5 on the x-axis, I'm going to have an open circle. That is my x-intercept. If I slide, whoops. Let's get rid of that. Delete. If I slide this over and I solve for y, I get a y-intercept of 3. So on the y-intercept, I go 1, 2, 3, and I write an open circle. And now I'm going to do a dotted line. And now I have to shade one of those sides. One of those sides is going to be the true value. It's going to be the true side. So I'm going to test a point. I'm going to test the point 0, 0. So if I plug in 0 for x and 0 for y, what do I get? Do I get a true or false statement? 0 less than 3, that's a true statement. So this point is going to be true, so I'm going to shade the true side. So that would be an excellent way of graphing that equation. That's the most efficient way. Copy. Let's do, if you didn't know that, well, the other way you could have done this is you can take this equation and you can put it in slope-intercept form. You could subtract 2x and you get y is less than negative 2x plus 3. We know that my y-intercept is going to be at 3 and my slope is going to equal negative 2 over 1. So at the y-intercept of 3, I'm going to write an open circle, and then I'm going to use my slope. Down 2, right 1. Down 2, right 1. And it's the same exact looking graph. It just used a different technique to find those points. We would still plug in, we would still test the point 0, 0. 0 is less than negative 2 times 0 plus 3. Is 0 less than 3? That's true. So we would still shade that left side. You can use any method. I just chose to use standard x and y intercepts because I knew that it was in standard form. Standard form provides us 2 intercept coordinates. And remember, the x-intercept is when y equals 0. That's why we covered that up. If y is equal to 0, we're left with 2x is less than 3. When we use the y, when we look for the y-intercept, we know that x equals 0. Well, if we plug 0 in for x, that would end up being 0, and we would just have our y is less than 3. So that's why we do that. That's the technique that we utilize. And the last problem today is graph the solution set of this system. So we know that both equations will give us a line. So we'll do this in green, we'll do this in blue. They're both in standard form. So if I look at and they're equal to, so that's nice. We know that we're going to get closed circles and solid lines. So if we look at the first equation, my x-intercept is going to be 2. So on the x-axis at 2, I'm going to make a dot. My y-intercept is going to be 2. And then I draw a solid line. And now I have to test. Remember testing. I got to test a point. So let's test a point for that equation. X plus y is greater than or equal to 2. Let's test 0, 0. 0 plus 0 greater than 2, that's false. So this side, the left side of this equation is going to be false, and the right side will be true. So I'm going to shade, and remember we do little teeny hairs to begin with. And now let's do the blue equation. My x-intercept is going to be 1. So my x-intercept is going to be 1, and then my y-intercept, this is a little tricky. We might have to do a little bit of work here. So if x is 0 for y-intercepts, we end up with this. We have to multiply by negative 1 on both sides. When we multiply both sides of the equation by a negative, I have to flip the inequality sign. So I get negative 1. So my y-intercept is going to be negative 1. Let's draw that. Negative 1, it's going to be a closed circle. It's going to be a solid line. And I'm still going to test the point 0, 0. So my equation is x minus y is greater than or equal to 1. I'm going to plug in 0. Is 0 greater than 1? That's false. So I know that left side, or the upper side of this blue line, is false. So I know that my true side is going to be going down. So I do little teeny hairs. And we're looking for the true. Where is it true for both situations? That would be in here. So if I picked any point, let's take a point to test, make sure our answer is correct. Let's take this coordinate. That point is 1, 2, 3, 4, 1. 4, 1 technically should be true for both. So if I plugged it into the green equation, is 4 plus 1 greater than 2? Yes. If I plugged it into this equation, is 4 minus 1 greater than 1? Yes. So good. That's a good test just to make sure that I did it correctly and my solution worked out. So that would be, you don't have to necessarily test. That's not part of the solution. The solution would look like this. But I'm just checking my answers. Sound good? Good luck.